This section is about vectors. Grade E students will be able to find the magnitude of a vector. Grade C students will be able to find the direction of a vector and resolve vector into Cartesian components. Grade A students will be able to solve unfamiliar problems using vectors. Section 4, Vectors, page 10 of the M1 booklet. A vector has magnitude and direction. A unit vector is a vector of magnitude 1. The unit vector in the direction of the x-axis is called I. The unit vector in the direction of the y-axis is called j. All vectors can be written in terms of I and j in the form xi plus yj. So for example, in the diagram below we have the vector r, but it could also be represented by xi to the right and yj upwards. So we would say that r is equal to xi plus yj. A vector written in this form is written using ij notation. Example 1. Represent the vector in the diagram in ij notation. So across, we go from 1 to 4, so that's 3. Vertically, we go from 1 to 5, which is 4. So r is equal to 3i plus 4j. Adding and subtracting is much easier in ij notation. So given in example 2, we're given a equals 3i plus 4j and b equals 2i minus 6j, and we're to find a plus b and a minus b. So a plus b equals 3i plus 4j plus 2i minus 6j. 3 lots of I plus 2 lots of I is 5i. 4 lots of j take away 6j is minus 2j. So a plus b is equal to 5i minus 2j. For a minus b, we have to be a bit more careful. We start with a 3i plus 4j, which is a, but since we're minusing the whole of b, we'll need to put it in brackets to get our signs correct. So minus, open bracket, 2i minus 6j, close bracket. So multiplying out the brackets, minus times 2i is minus 2i, minus times minus 6j is plus 6j. Collecting like terms, 3 lots of I minus 2i is 1i, 4 lots of j plus 6j is plus 10j. Sometimes we need to find the magnitude of a vector, which is, you can think in some terms as the length of the vector. Now xi, because I is a unit vector, has magnitude x. Yj, because j is a unit vector, has magnitude j. Magnitude y, sorry. So what we've got is a right-angled triangle, one with the two shorter lengths being x and y. Now we've got r here as being xi plus yj. So the magnitude of r, which is usually denoted by r with vertical lines on either side, is the square root of x squared plus y squared using Pythagoras' theorem. We should be able to write a vector given in terms of direction and magnitude in ij notation. The process is called resolving a vector into Cartesian components. So in this case we're to resolve the vector r with magnitude 6 and bearing 0, 3, 0 degrees into Cartesian components. So quick sketch, the vector pointing north, and then 30 degrees from north, that is what a bearing is from GCSE. The vector has magnitude 6. We want the Cartesian component, so we'll need the horizontal length and the vertical length. Now from trigonometry, our horizontal length is opposite the 30 degrees, so that would be hypotenuse, which is 6, sine of 30 degrees, On the adjacent side will be hypotenuse times cos of 30 degrees. Now 6 sine 30 degrees is equal to 3. 6 cos 30 degrees is equal to 3 root 3. So r would equal 3i, because that's how much it's going horizontally, plus 3 root 3 times j, because that's how much it's moving vertically. But I also have to be careful as what's pointing upwards and downwards. We should also be able to reverse this process. So find the magnitude and bearing of 3i minus 5j. So 3i means we go to the right by 3, and minus 5j means we go down 5. We often denote r, the resultant vector, with a double arrow. Now for the magnitude, we use Pythagoras, so the square root of 3 squared plus 5 squared. Which gives 5.83 to 3 significant figures. For the bearing is measured from north. So we already have 90 degrees before we get to the 3i part of the vector. We can use trigonometry to find theta and then add that to the 90 degrees. So from trigonometry we've got the opposite side and the adjacent side. So tan theta equals the part of TOA in SOHCAHTOA, opposite over adjacent, so 5 over 3. So doing tan inverse of 5 over 3, we get 59.0 degrees for 3 significant figures. We need to add that to 90 for the bearing. So we've got this 90 degree angle here. And as a 3 figure bearing we get 149 degrees.